Okay, another one of the things we need to cover is the idea of accuracy and precision. So let's think a little bit about accuracy and precision. So we're going to define accuracy as an indication of how close a measurement is to the true value. So, for example, if you know something is 12 inches long, and when you make a measurement, it looks like the measurement came up to 8.5 inches long, you're going to say something about the accuracy of the measurement. Precision is an indication of the scale of the measuring device that was used, and it's also an indication of if you have multiple samples, let's say you measure it 3 or 4 times, how close those measurements are to each other. So for example, along that line, if we would use the analogy of a target, um, here we have, let's say we shot 4 arrows at the target, and they are all right in the bullseye, and they're in a nice tight group. Well, that would be something that would be both accurate. It's accurate because the arrows hit the bullseye, and it would be precise because those arrows are in a nice tight group. Another option might be that we have something that's accurate, that if we, let's say we average those shots together, they would definitely, between the four of them, they would hit the bullseye, but it's not terribly precise because their grouping pattern is a little bit broader. This would be an example of something that is not accurate, but very precise. Look at that nice tight grouping. Let's say we measured something 4 times and those numbers were almost identical. But of course, because of the system, excuse me, let me scroll that back, because of maybe the system or something was inaccurately calibrated, it's not very precise. And so we never get very close to the true value. And sometimes, just the way things work out when you measure them, you don't have you have an answer that's neither accurate nor precise. It's just it's the best you can do with the limitations you've been given. So I'll illustrate it this way. So let's say that if you have a square and you measure it 3 times, and let's say that we don't know this to start off with, but let's say that the actual length is 12.00 inches. All right. Let's say the first time we measure it, we come up to 12.7 inches. So that's not very close to 12, but it's where it is. Let's say another time we measure it, we come up to 12 inches. And then a third time we measure it, we have a different measuring device each time, by the way, and we come up with 11.289 inches. Now, if we were to ask which is the most accurate and which is the most precise, well, let's think through this. So our first answer, 12.7. What our measurement is claiming is that this square, based on this measuring device, it's going to be larger than 12.65 inches, but it's going to be smaller than 12.75 inches. And that's not exactly true because we know it's 12.00 inches. So that one is neither very accurate nor precise, but it happens to be more precise than this measurement. Here we're just saying it's 12 inches. We're not saying that it's 12.1 inches or 12.5. We're just saying it's 12 inches. Not as precise as this one that's measured to the tenths, but it turns out to be more accurate than that one that's measured to the tenths because the true value is 12.00. And one more measurement. This one says it's measured at 11.289 inches. Now this was the most precise of all three of our measurements because it's measured to the thousandths even. This would be to the tenths, the hundredths, the thousandths position. But if the true value is actually 12.00 inches, in spite of all the precision here, that's not a very accurate number. So that is something about accuracy. Often, you are going to be able to identify how precise a number is based on the number of significant figures. Now, we're going to talk about significant figures in a second. So just be thinking in your mind, okay, significant figures are going to be, if I see a number, it's going to be the significant figures that are going to tell me how precise the number is. And you'll understand what that is in just a second. Let's do a little bit of practice with measuring here. So we're going to switch to a different picture. All right, so here I have a meter stick down here, and I have something that we're going to measure some marks off of that are right above that there. So let's say that I want to read a measurement that's closest to the 0.05, 0.05 centimeters. So let me introduce you to this meter stick. This meter stick is at the 3 centimeter mark, the 4, the 5, the 6. So we're basically seeing 3 to 8 centimeters here. If I were to talk about the way it's graded, the gradations are, this would be 4 centimeters, that would be 4.5 centimeters, that would be 4.6 centimeters, all right? We could also look at this really closely. If we look at it really closely, see if I can get a, yeah, there we go. Zoom in on this thing here. Now, it might be a little easier to say that we could talk about 4.1 centimeters, or we could talk about something in between there. So like right there in the middle of those two, that would be 4.05 centimeters, all right? So, for example, I'll pick any one of these marks that we have up here, and let's say we stick with that one right there. And you might be able to tell there's a little tiny little tag off of that mark. Let's say that we're going to want to determine the length of, or the position of that little tag on the mark. So we know that it's at least 4 centimeters long because it's in between those two, but it's not quite to the 4.1 centimeters. So it's going to be between 4 and 4.1. And I'm going to just estimate there because you always, when you're measuring things, you go to the value that you know it's absolutely true, and then you estimate to the next factor. So I'm going to say that that little tag mark is really 4.08. I'm just going to make that guess. That's my best guess of where that is. And so if I say it's 4.08 centimeters, that's even, that's down in the hundredths of a centimeter mark, or that is down in the tenths of a millimeter, because here to here would be 1 millimeter, so we're in the a fraction of a millimeter. So that's what we mean by precision measuring. It has to do with how precise we are in it. Let's look at another example. A lot of times we're going to be measuring volumes and we're going to be measuring masses of things. If you're going to measure a volume, if you have an aqueous solution, you will end up with this meniscus here, this rounded smile look that's associated with the fluid inside a graduated cylinder. In order to make a precise reading, so we're talking about that word precision, you want to have your eye at the level of the bottom of that meniscus, because you'll be able to see that there's a bottom of the meniscus and a top of the meniscus. When you record the volume of something, you don't talk about this volume being at this height. We're going to talk about that volume being right there at the bottom. And in order to increase our precision, you want to make sure that your eye is level with that, so that you're not looking down on it or neither looking up on it, because that will give false readings. All right, let's get some practice here. So here we have a graduated cylinder. We're going to try to measure it to the 0.01 mils. Okay, that's a hundredth of a mil. So let me introduce you to the gradations. This line right here is 6 millimeters. 6 milliliters, excuse me. This line right there would be 7 milliliters, and that would be 8. So if I just am looking at this, I know that it's going to be more than 6 and less than 7 milliliters. So it could be 2, 4, 6, someplace in between 6.6 milliliters and 8. Let's see if we can get a little bigger picture there. There we go, zoom in. Now we know that it's more than 6.6 milliliters. So we're going to estimate this next one, and our eye is just about level with that. I'm going to say that's 6.62 milliliters. And that's how I would report that number. Let's look at another one. Here I have another graduated cylinder, and this would be 10 milliliters. This would be 11, 12, 13, 14, and 15. So we're going to see what we can do with this. I wonder what the volume of that is. I know that it's at least 10 milliliters, and it's actually more than 11, and it's right in kind of between 11 and 12, so that almost looks like 11.5. See, let me look a little closer to that. Man, and that's about as close as I'm going to be able to get. I'm going to say that is, so this would be 10 right there, 10.5, 11, 11.5 is right there. I'm going to call that 11.5, I call it 11.50 milliliters, because it looks like it's just right on that line. So that's an example of what we mean by, measuring something as precise as we can, and just give you some quick practice with that. All right, so we'll say this a little different way, but for a quick review. So precision and accuracy. If you are measuring something, and we're going to talk about precision, that is a reference to how closely an individual measurement agrees with another individual measurement. And it also indicates the scale of the measuring device that was used. If we're talking about accuracy, we're talking about how closely one of those individual measurements are to the actual true value or the correct value. And we're going to do a lab in a week where we measure the density, and we'll be exploring that idea more. Anyway, that's a quick introduction to measurements, precision, and accuracy.